Hello and welcome to the Chemistry Academy. In this video we're going to go over precipitation reactions, which is especially relevant for the National 5 Chemistry course. If we start off with what a precipitation reaction actually is, it's a reaction where we react two solutions and end up forming a solid. Now you might have done an experiment like this in chemistry if you're studying chemistry at school, or your teacher might have shown you a demonstration where you mix two clear solutions, and as soon as they mix you get a bright yellow colour appear. The solution then becomes cloudy, and the reason it's become cloudy is because you've produced a precipitate, produced a solid. So if you run water out of your tap and it looks a bit cloudy, the chances are you've got a precipitate in your water. Okay, so if the actual reaction I was talking about there that you might have seen in school is where we react lead nitrate with potassium iodide. And what happens is the lead pairs up with the iodide to make lead iodide, and the potassium pairs up with the nitrate to make potassium nitrate. Now the lead iodide is insoluble in water, so it ends up being a solid, which is what our precipitate is. The potassium and the nitrate ions, they, as potassium nitrate, are soluble, so they stay in solution, and they are known as the spectator ions. So the spectator ions are the ions in the reaction that don't actually take part in the reaction. They stay the same the entire time. So the potassium and the nitrate are aqueous at the end, and they were also both in aqueous substances to start with. So the spectator ions do not take part in the reaction, they just watch, if you like, so they don't end up changing over the course of the reaction. They're not like a catalyst. Catalysts don't also end up unchanged at the end of a reaction, but the catalysts speed up the reaction. The potassium and nitrate are not speeding up a reaction here. So although it's kind of like a catalyst in that they remain unchanged at the end of the reaction, they're not the same as the catalyst because they're not speeding it up. Okay, so just remember the spectator ions are the ions that remain unchanged, and you want to look for the things that are still aqueous at the end. Just double check that they were aqueous in aqueous substances to start with. So these are our spectator ions. This is our precipitate, the solid that forms in the reaction. Okay, so once we've done a precipitation reaction, we can then separate out our precipitate if we want to use it for something. And in order to separate out the precipitate, all we have to use is the method of filtration. So for filtration, you have a filter funnel with filter paper in it, and you would pour your solution into the filter funnel. Your precipitate gets gathered in the filter paper, and then the liquid, so whatever the potassium nitrate solution is, would then drip down and be collected into your beaker. That's then known as the filtrate. So the solution that comes off the filtered mixture is known as the filtrate. The solid that you end up collecting is what we would call the precipitate. You might have heard of the phrase, if you're not part of the solution, you're part of the problem. In chemistry, we say if you're not part of the solution, you're part of the precipitate. Okay, so if they're not in the aqueous solution and they're floating about as a solid, they can be known as a precipitate. You will quite often get asked questions in your chemistry exam that involves you working out if a reaction would form a precipitate or not, and it's actually a very straightforward question to answer, just a lot of people don't know where to start. So we've got a few examples here. Let's say we're going to mix calcium chloride and potassium phosphate. Now, much like when the lead nitrate and the potassium iodide reacted, all that happens is they basically swap name endings. So we would end up making calcium phosphate and potassium chloride. So that would be our two products that we end up making. Calcium phosphate and potassium chloride, because the name endings just switch around. Okay, because the ions switch around. So the lead ion matches up with the iodide ion instead, and the potassium ion matches up with the nitrate. Just remember as well that, I'll just grab my black pen, that these are shown as the chemical formulas, but these are ions. So the nitrate is NO3- as an ion, you would find that on page 8 of the data booklet. And the lead, because it's then a transition metal, it just takes the charge of whatever the nitrate needs to balance, so it would end up with a single positive charge. So that would be the two separate ions we have here. Potassium ion is always a single positive charge, and iodide ion always has a single negative charge. So what's happening in the reaction is the nitrate decides to pair up with the potassium, and the lead just pairs up with the iodide. Okay, it's kind of like a life swap. I don't know if you guys will be old enough to know that show, but that's essentially what happens. They just swap partners. Okay, kind of like, what do you call those ceilidh dances where you oh, I can't remember the word now. There's a word for it when you're doing a ceilidh dance and you swap partners. Progressive, yeah, so like a progressive Canadian barn dance. Anyway, right, so back to this question. We've got calcium phosphate and potassium chloride. To work out if either of them are a precipitate, all we have to do is look up the solubility table in the data booklet. So it's on page 8 of the data booklet. You can see it here. And the way it works is you look up the metal ion down the side and the non-metal ion group along the top, and you basically just see where that row and column match up. So if we look up calcium phosphate, we go down to find calcium and then along until we see phosphate, and we should be able to see there's an I in that box, which means that calcium phosphate is insoluble. Okay, so calcium phosphate is insoluble. That means that is a precipitate. So if that's made in a reaction, it's going to be a solid, and therefore it'll be floating about like a precipitate. The potassium chloride, if we go down to potassium along to chloride, that's very soluble, which means that that's going to be in the solution. So it's not going to be part of the precipitate or part of the problem. Okay, so this reaction would produce a precipitate, and that precipitate is the calcium phosphate. Okay, so if we were to mix calcium chloride and potassium phosphate together, we would find the solution went cloudy, and the reason it went cloudy is because it formed calcium phosphate, which is a precipitate. If we look at the next one then, so again we're swapping the name endings. My advice in your exam would be to do something similar when it comes to these questions and identify which new ending's going with which. You might not have different coloured pens in your exam, so what I would maybe do is underline one of them with the other ending and then don't underline the others, or do like dashed lines for the other options. Okay, because what tends to happen is people check for the first switching and then they forget, and then they end up looking up barium bromide, and you will always find that the reactants you're starting with are always soluble. So just don't forget to swap the name endings. So if we look up barium iodide, we go down to barium along to iodide, and that is very soluble, so that's not going to be a precipitate. You can also, if you do think you're going to end up forgetting to swap the name endings, you can just write down what's made if that's easier for you. So you'd make barium iodide and magnesium bromide. So like I said, the barium iodide is very soluble, so that's not going to cause a precipitate. Down to magnesium bromide, and that is also very soluble. So that reaction will not produce a precipitate at all. So the solution will remain clear, not end up cloudy. So then the last one, ammonium carbonate and nickel sulfate. So we end up making ammonium sulfate and nickel carbonate. So I just note that down. Ammonium sulfate. Oh, sorry. So then if we check those substances, so ammonium sulfate, go down to ammonium along to sulfate, that's very soluble, so that's not going to be a precipitate. And then we go down to nickel and along to bromide, along to carbonate. See, this is why it's word to write it down. So nickel to carbonate, that is insoluble, which means that will be a precipitate. So if you mixed nickel ammonium carbonate with nickel sulfate, your solution would go cloudy, and it's cloudy because you produced a nickel carbonate precipitate. Okay, so that's commonly what you get asked about precipitation reactions. You could just be given a list of compounds and asked which one would be a precipitate. That's very straightforward. You just look them up and check to see which one is insoluble. One last little bonus thing though, so for this reaction here, we've made lead iodide, we've made potassium nitrate. We've managed to obtain our lead iodide by using filtration. If we wanted to obtain a dry sample of the potassium nitrate to use for something, that's still in solution. That's going to be in our filtrate. So in this case, that will be containing the potassium nitrate. Okay, if we want a dry sample of that, all we need to do is take the filtrate and perform evaporation. So we would perform evaporation of the filtrate. So evaporation, remember, is where you have the wee evaporating dish above a tripod that has a Bunsen burner underneath it, and you have your filtrate in there, and then it would evaporate off the water and you would end up with your dry sample of potassium nitrate. So for this particular example here, our precipitate would be lead iodide, solid. And yeah, like I said, if we wanted then a sample of our other product, potassium nitrate, as a dry sample, we would just take the filtrate and evaporate off the water. Okay, so I hope that was helpful. If you found it useful, please give it a like. Don't forget to subscribe, and I'll see you again soon.